Well, I hope you guys have been resetting all your passwords, to whatever website you have been to. You guys heard of that?
What's that
bleeding
about?
heart,
right?
Okay, Heartbleed. Okay, is the name of the bug. They name it Heartbleed because it's based on a feature of OpenSSL which is called Heartbeat. Okay, so in other words, when you make a connection, through SSL, you can basically send a little pulse over and say, okay, is the other end still working? Are you still connected? Are we still connected? Okay, so it's called a Heartbeat packet. But somebody was able to figure out how to use that one to get into OpenSSL and retrieve memory content back to the client in this case. So okay, let's just say that you're trying to attack Yahoo.com. Okay, so what you would do is to just make a connection using SSL to Yahoo.com, and then you just have to send those packets, those tricky packets over, and it will reply back with memory content on the server. The memory content that is retrieving can include passwords and usernames already decrypted. So that means you can retrieve passwords, usernames, and also certificates, entire certificates this way. And that's why that particular bug was very, very serious. And 500,000 servers, that's the estimate of a 500,000 number of servers are affected by this particular bug. So if you use Yahoo Mail, for sure you have to change your password. I mean, there's no. Well, if you use Yahoo Mail, you really should do that, every week anyway, or Hotmail for that matter. But if you use, online banking accounts and stuff like that, any credit card account, you really should go change your password as soon as possible, because there's no one can actually estimate how much stuff is lost, because of this, because whoever is going quote unquote doing the attack leaves no trail in this case. So there's no way to really estimate, how much damage has been done already so far. Yep.
Okay, but if you change your password, is the bug still active?
No, the bug is now fixed for the most part. So most commercial websites, have changed their certificates and also changed the OpenSSL. So they plugged that, security hole already. It's just that, before the security hole was plugged, it was in circulation for a pretty long period of time, 2 years. So that means, if any hacker, knew about this bug and have been, sniffing and collecting data over the past 2 years, they would have collected a lot of stuff already. And because there's no trace, it doesn't leave any trace, so no one could actually estimate, did no one know about this bug before, and did someone know about it and just not say anything and just keep exploiting it? So nobody was able to tell, the extent of the damage. But you can rest assured that the Los Rios, systems are currently all patched now. I checked. Yep. Go ahead.
For educational purposes, how would one specifically do that attack?
You can probably look it up.
Really?
Yeah, it's actually well published at this point. So if you just look for Heartbleed exploit, you will find instructions of how to do it. Yep. All right, so what we'll do today is we'll finish the homework assignment, and then we'll also work on the practice exam questions for exam 2. Exam 2 will be on the Thursday after spring break. So we have 2 weeks from today in real time, but if you're not going to study during the break, we have 1 week from today.
1 week from today, gotcha.
But you have a few days left, if you do things in the break that will help you forget stuff that you have learned already. Oh, okay, I shouldn't have done that. All right, so what we'll do is we're going to take a look at the homework assignment. So let me click on this one and open it up. All right, so this is your last homework assignment. There's a new one also, and we'll talk about the new one shortly. All right, so this is your homework assignment. It is a flawed binary search algorithm. And your job is not to fix it, but to basically just trace it and find out what happens when you have a flawed binary search algorithm. All right, so there we go. Let's go ahead and get started. This is the precondition. On line 1, B gets initialized to 0. On line 2, bar A bar minus 2 is used to initialize E, which is 3, because in this case bar A bar is 4. 4 minus 1 is 3. Then we proceed to line 4. Line 4 is initializing M to the floor of B plus E divided by 2. B plus E is 3. 3 divided by 2 is 1.5. The floor of 1.5 is 1. So that's why M gets a value of 1. On line 5, we have one comparison. We compare A bracket M, in this case is A bracket 1, because M equals to 1, which has a value of 6. We compare that and see if it's larger than K, which has a value of 9. The answer is false. It is not true. So we have to go to line 8, which is the else branch of the conditional statement. We copy the value of M, which is 1, to B. So B is now 1 instead of 0. And then we move on to line 10, because line 8 is the only line in the else branch of the conditional statement. Once we are done with that, we get out of the conditional statement. So we are now on line 10. Line 10 has to evaluate another expression. A bracket M is A bracket 1, which has a value of 6. K has a value of 9. 6 equals 9 is false. So now we have to evaluate the other side of the disjunction. B is 1, E is 3, B is greater than E is false. So now we have false or false, which is false. We go back to the first line of the loop, which is on line 4. This time B is 1, E is 3, 1 plus 3 is 4, 4 divided by 2 is 2, and the floor of 2 is also 2. On line 5, we compare A bracket M, which is A bracket 2, which has a value of 8, with K. K has a value of 9. 8 is greater than 9 is false again. So we move on to line 8. Line 8 is copying the value of M, which is 2, to B. So B is going from 1 to 2. And then we get out of the conditional statement. We end up on line 10. A bracket M is A bracket 2, and it has a value of 8. 8 equals to K, which is 9, is false. So now we have to evaluate the right-hand side of the disjunction. B has a value of 2, E has a value of 3, 2 is greater than E is false. We have false or false, which is false. We go back to line 4 again. On line 4 this time, we have 2 plus 3, which is 5. Divided by 2, we have 2.5. The floor of 2.5 is also 2. So now we have 2 here. And now we move on to line 5. Line 5 is comparing A bracket M, which is A bracket 2. So it's almost the same as last time, except we really have not seen it repeating itself. So we have to finish this part here. A bracket M is A bracket 2, which has a value of 8. K has a value of 9. 8 is greater than 9 is false. We go to line 8. B gets the value of M, which is 2 again. And then we go to line 10. And A bracket M equals K is false. B is greater than E is also false. At this point, we can stop and say that it is an infinite loop, because we have just gone through 2 complete iterations with no updates of any kind to the actual values of the variables. Are there any questions about this trace? Nope. Okay. Moving on. Yep.
I guess I kind of missed out maybe on the beginning of the last lecture, but if you went like 2.5 iterations, or just still be docking more points, or is it like?
Well, it depends on how you explain it. Okay, if you explain and say that at this point all the variables are the same as the previous iteration, and that's why the rest. If I trace it through, it will be the same behavior as the last iteration, and it will still be okay.
Okay, as long as you said that part to explain where you stopped.
Correct. Yep.
How many points was this assignment worth?
I cannot remember.
I didn't notice it. Yeah.
I can't remember. Okay, but I can find out.
Do you have more than one variation?
Yeah, for this class and the previous class.
Yeah, because
I just never mentioned it.
You might have.
my line 5 is different.
The line 5 is different.
I have the A bracket M is less than K.
Yeah, that's good.
Oh, okay. So I might be retrieving the wrong file then, or I'm opening.
Yeah, because
using
when you
the wrong
scroll
file.
down, I don't think you switched any. classes,
Okay.
but it said the 9 o'clock because it said it was overdue by over an hour.
Oh, okay.
Which, if memory
Right.
serves, it cuts off right before this class starts.
Yep, you're correct.
Yeah, 'cause I was like,
I'm
man, I'm hitting
I think
this
I'm pretty
wall.
good at that class now.
But the approach is the same. The approach is the same. Yep.
Okay.
Okay, this
Yeah,
is
I think
worth
the-
20 points.
Those were different.
Yep.
I have a question. For example, you just wrote infinite loop keeps continuing, but you didn't write out the explanation. How much would be deducted?
I have not decided yet.
Alright. I didn't write the explanation.
It is a
so I just wrote
mystery.
infinite loop.
No, it depends on how many people make that mistake.
Oh.
The
Alright.
more people make that mistake, the heavier weight it will carry.
Mistakes.
He's saying that if we didn't write infinite loop,
No, I mean the
There's a
explanation
difference.
afterwards, like
So,
why
like,
it is infinite. I
okay,
just wrote
so-
infinite loop, that's it.
because B plus C equals,
No, it's the same one. It keeps retrieving the wrong file. This is the
Well.
right class. Oh, wrong class. Never
Yeah.
mind.
Well, every time you go to that particular.
Okay, there's a
I have a feeling where you have to get something.
there's a
slightly-
lapse.
And would that alter anything?
That will alter the values for sure.
Okay.
Okay, that's
Some of the values were a little different, but there's
Yeah.
3 of them, and I was like, you know what, I submitted it, let's just see how this.
Yeah, I make
plays
it
out.
just enough, just different enough to
Or
differentiate the two
Yeah, 'cause my
classes.
left-hand sign was switched around to, now it's all correct, alright.
Now this is the one. Yeah, that's the one that you guys are doing. Okay, let me trace this one then. All right, that's fine. Yeah, we'll trace this one also.
Oh, so that last one was the wrong one?
This is the
But
right
it's-
way.
It essentially goes the same way.
Well, it's about the same,
way,
but it's
except
not.
we're going to 6, you know.
Right, the branches are different.
Yeah.
Okay, so I'll just kind of quickly go through this one too. And I'll only make a note, when it's actually different, like now. Okay. Okay, so this time we're comparing A bracket M, but this time we are checking for less than. So A bracket M is still A bracket 1, which has a value of 6. 6 is less than K, which is 9, is true. So this is why it's different, because this time we take the then branch instead of the else branch. But we are still updating B instead of E. So B is still going to be updated to a value of 1. And then after line 6, we still get out of the conditional statement because line 6 is the only thing in the then branch of the conditional statement. When we're done with it, we get out of the entire conditional statement. We get to line 10. So when we get to line 10, we have to evaluate the disjunction. But the same result is going to be the same. It's going to have the same result because A bracket M equals to K is still false. B is greater than E is still false. So the entire thing is false. You go back to line 4, and this time we have 1 plus 3 divided by 2, which is 2. The floor of 2 is also 2. And then we move on to line 5. It's still comparing the same element because we're still comparing A bracket 2 to K. And the less than relationship is still true. It's just that instead of taking the else branch, we're taking the then branch onto line 6. So in this case, B is updated to a value of 2, and we get out of the conditional statement. We get to line 10. The entire condition is still false, and the rest would be pretty much the same thing. We just repeat this loop one more time, and then we can make the conclusion. So it's about the same, but it's slightly different also. Okay, so sheet 3 is not going to be much different, okay, but the last one is going to be a little bit different. The last one is actually the easy one, because if you look at the last one, it's going to exit really quickly. B gets an initial value of 0, E gets an initial value of 3, we go to line 4, M gets an initial value of 1. So that part is basically just copy and paste from the other ones. And then on line 5, we have A bracket M, which is A bracket 1, has a value of 6, less than K, which is also 6 in this case, is false because it is not less than. So that means you have to go to the else branch, which is on line 8. We update E regardless, okay, because that's what the code is saying. Update E on line 8. And then when you get to line 10, the first condition of A bracket M equals to K is true already. and that's all you need to do is to say that that condition is true, because we are using short-circuited evaluation in this class. Yep.
Can you go back to the trace that you did just before this one?
Sure.
So if we didn't do the short circuit,
It'll be, yeah, like some points will be taken off. Yeah.
Short circuit what?
unfortunately.
Short-circuited evaluation.
Was that the last, what does that mean? With the,
That means, with a disjunction, if the first condition is true, you don't evaluate the second one.
So the question was, should
Yep.
you not do the second one then?
It's not wrong, but it's.
You do not evaluate the second one.
But you still write it in the
You
comment.
did that.
Well, remember when we talked about that, in class, I basically said only write down the first portion. If the first one is true and you can make a conclusion right away, you just write the first one.
you got me.
It's not going to be a whole lot of points, but there will be some points off, because, it is important to remember that we are using only short-circuited evaluation. Okay. Any other questions? Yep.
We also put post or,
You mean with this one? With an infinite loop, there's no post.
so a short circuit
It
evaluation.
would be nice if we could.
No, in the third one we do. Okay, in the last trace we do have the right post here.
Oh my God, I'm
Because
getting mixed
if
up.
this one actually finishes, this one gets the
Yeah.
complete circle of what we're trying to do, so
Yep.
to speak. The other one doesn't.
The other one does not. That's
It's
correct.
a continuous circle.
Yep. Yeah, this one is important to write down post because it does get out of the loop, even though the algorithm itself is incorrect. It does get out of the loop. Yep.
In line,
Row sheet. Okay. Yep. Go ahead.
in line 2, I see where you're getting the 3, and I'm looking at the absolute of A minus 1. I look over here and I see 2. How do you get to 3 if it's 2 minus 4?
2? Wait, what are you?
That was over here, like line G. The A line is getting a pre 2.
Bar A bar is the.
A bar
number of
0's
elements.
value is 2. That's the value of the element. A bar 0.
Bar A
Not
bar
not
is
bar, but bracket.
Because the bar, I'll admit, the bar A bar, that stuff I'm still.
is the number of elements in the array.
Like 0, 1, 2, 3. That's 4 values. And then that
Oh,
minus
okay.
1.
Alright. Okay, now I get it.
Okay. All right. So with this out of the way, I'm going to show you your new homework assignment, and then we'll go over the practice questions.
When's the new one due? Next Thursday?
It will say, when you get to the homework assignment.
And when's the test? Is it the Tuesday we get back or the Thursday?
The
Thursday.
Thursday
Okay.
after spring break.
Okay.
Yep, not during spring break. I'm not going to be here.
Okay.
So this is your new homework assignment. Your new homework assignment is the only one that has to do with subroutines. I have to give you something like this, as a chance to practice, this stuff before the exam. Okay, and this is your, homework assignment. And let's take a look at the due date. The due date is April 22nd, which is 2 days before the midterm, the second
So
exam.
the Tuesday
We come back.
after break.
Yeah, the Tuesday after break, which is not the usual 1 week, from the time that I assign the homework assignment. However, this one is going to be easy because I think we have seen something like this already in class, and we're going to see it again in the practice questions for exam 2. So I think for the most part, it's just going to be like, oh, okay, we can do this. Let's take a look and see whether that really is the case or not. This is the exam. It's the same practice questions as the earlier class. So even though this is, from the earlier class, yours is exactly the same. So there's really not much difference. If you look at the question number 1, do you see any resemblance with your homework assignment? Okay, let me pull up the homework assignment first. Then you can see, you can do a side-by-side comparison. Okay, here's a side-by-side comparison. This is question number 1 that I'll go over today, and this is your homework assignment that you'll have to do by Monday, by Tuesday, after spring break. Do you see any resemblance? So if I trace one, the other one, should be about the same. Okay, I wouldn't call it exactly the same, but it's about the same. It's closely related.
Multiplication, addition.
Yep.
0.
All right. So in your homework assignment, you have 2 invoke statements. It's not a typo. You do have 2 invoke sub 1 in your homework assignment, as opposed to just 1 in the practice test. So I'm going to hide this one first, and then work on the practice question in the practice question. So I'm gonna change the form of the questions in exam 2. So instead of asking you guys to give me the entire full trace, as something that I use for grading purposes, I'm just gonna ask you, when x is initially 0, tell me the value of y when the algorithm is finished. When x starts with the value of 2, tell me what is the value of y when it's done. And when x is 4, tell me what is the value of y when it's all done. So you have to decide whether you want to go for a full trace or whether you want to just analyze the algorithm and come up with the answer, somehow. Yep.
Do you think you could still give us the template if we wanted to do a full trace as like scratch?
It becomes a little bit harder because with subroutines you have to allocate columns
You're right.
dynamically. So I would bring maybe graph paper, okay? Because graph paper already have horizontal and also vertical lines. So that makes it easier for you to draw the line and kind of like line up columns and stuff like that. And I can go to Dollar Tree and see if they have an inexpensive graph paper. But I'll bring my calculators, my bag of calculators. I think I'll bring those too, just in case someone decides, okay, I cannot trust myself multiplying by 2, or finding the remainder of a division. Then they can use a calculator. But most calculators do not give you the remainder of a division.
They give you point something.
Yeah, then you can just take that fractional part, multiply it with a divisor, and still get back to the remainder. But if you know how to do that already, you probably don't need a calculator to begin with. All right, so getting back to this one, so we'll go ahead and trace it. And I'll start a spreadsheet. Start a different one. Okay. And we'll take a look at the spreadsheet and also take a look at the algorithm. Copy the algorithm first. So we'll do a copy here. Define sub xyz. If x is greater than 0, then x gets x minus 1. Invoke xyz. Y gets y times 2. Else y gets 1. And if, and find sub, invoke xyz. And then we have line numbers. And now we are ready to trace it. All right. So when you trace something like this, I use a column for comments because we do have one conditional statement starting on line 2. Line number, we have 2 variables x and y, and those are the columns that we need initially. The precondition is I have to give you a value for x to begin. That's the initial condition. So the first one has x being 0 to begin with, but I didn't tell you anything about y, so y would be unknown to begin with. The first line and the only line that is outside of the definition of a subroutine is line 10, so we have to start with that line. When we invoke a subroutine, we are going to allocate the leftmost available column, in this case is column E, and use it to remember where I'm supposed to continue on, after the subroutine is done. In this case, it is post because line 10 is the last line of the entire algorithm. And then we can continue into the subroutine. When we continue execution in an invoke statement, we always start with the first line of the subroutine that we're invoking, and we identify which subroutine we're invoking by its name. So when we say invoke XYZ, we look for the subroutine definition of XYZ. So it's the name of the subroutine that helps us link the invoke statement with the subroutine that we're invoking. In this case, XYZ starts on line 2, and the first thing it does is to compare x to 0 and say, is it greater than 0? Nope, it's not, because x has a value of 0 to begin with. So we skip over the entire then portion, we get to the else portion, and we get to line 7, y gets a value of 1, and then we are done with the conditional statement. We continue execution on line 9. Line 9 is the end of the definition of a subroutine. We have 2 things to do when we are at that point. First, we have to retrieve the rightmost active return line number. In this case, is column E. It tells us where to go back to, which is post. So we make a note that we are going to post next. But we also have to remember to deallocate the column, because once we get to the end of a subroutine, whatever we allocate for that subroutine invocation, needs to be deallocated. And I use a strike through to indicate, this is the deallocation of column E. And then we continue execution and post. We are done. So the answer to the first part of the first question is 1. Y ends up with a value of 1 after the execution of the entire algorithm. Yep.
Is this practice test available on Moodle?
Yeah, yeah, it is. All right, so the second test case is what happens when x equals to 2. So we'll go ahead and take a look at that one. By the way, your homework assignment only has 1 test case, so you don't have to go through all of this stuff. All right, so in here we go to, well, let's open up new spreadsheet. I'm just going to copy and paste, some columns, and then we can erase, a good portion of that, and change the initial conditions. So instead of x starting with a value of 0, x is now starting with a value of 2, and we'll see what happens. So let's go take a look at the algorithm and then trace it. On line 10, we have an invocation. So we allocate a column for return line number, and remember where we're supposed to go back to, and then we go to the beginning of the subroutine that we are invoking. It checks x is greater than 0. It is true in this case because x has a value of 2. Go to the then branch on line 3, subtract 1 from x. Go to line 4, we invoke the subroutine again. The fact that we are inside the very subroutine that we're invoking doesn't change how you do it. Okay? So we are going to do exactly the same thing, which is to allocate the leftmost available column. And remember where we're supposed to go back to. Where are we supposed to go back to after this invocation? Line 5. Okay, that makes perfect sense. And once you remember where you're supposed to go back to, now you can continue execution in the subroutine that you're invoking. And which line are we going to? Line 2, that's right. Okay, you always start from the beginning of the subroutine that you're invoking, never in the middle of something. Okay. X is greater than 0 is still true because x has a value of 1 at this point. Then we move on to line 3, we subtract 1 from x, x goes from 1 down to 0, and then we get to line 4 again. Okay, allocate another column. The leftmost available column at this point is column G. Remember that we have to go back to line 5 after this invocation of the subroutine, and then continue execution in the subroutine starting on line 2. So right now, at this point, we actually have 3 concurrent invocations all at the same time. Even though there's only one single subroutine, it is activated 3 times concurrently. They're all basically stacked up at this point. On line 2, we do the same comparison. X is greater than 0. This time it is false because x has a value of 0 at this point. We go to the else portion, which is on line 7. Y finally gets its value of 1. And then we get out of the conditional statement. End up on line 9. Look up the rightmost active return line number. It is column G at this point. It tells us to continue execution on line 5. Then once we use it, we have no use of this column anymore, so we will deallocate it. So we deallocate this column, and then we continue on to line 5. Line 5 says double the value of y. Okay, y is 1 at this point. Double that, it becomes 2. Once line 5 is done, we get out of the conditional statement. Now we are on line 9. Do the same thing, and as last time, look up the rightmost return line number, and this time it is column F. It has a value of 5. Column G is not really there anymore because we just deallocated it. So that's why we have to use column F, which also tells us to continue execution on line 5. So now we make a note of that, and then we have no use of the return line number on column F anymore, deallocated. We are now onto line 5. Line 5 is doubling the value of y, so now it is doubled from 2 to 4. Then we go to line 9. This time it has to retrieve the rightmost active return line number, which is column E. Make a note that we are supposed to continue at post, and then we deallocate the column at this point, and then we continue execution, and we're done, because you cannot execute past post. Are there any questions about this trace? The most important part about this trace is the mechanism of invoking a subroutine and also coming back at the end of a subroutine doesn't really change whether you are doing it from within the subroutine itself. Okay, the mechanism is identical in all cases. Yep.
So if we put 4 in there, we're just gonna get a lot more return lines or invocations of XYZ.
Well, what do you think? How many columns will be used up just for return line numbers if we start with 4 in X? Yep. You have 2 more levels of invocation. And what would end up as the value of Y as a result?
16.
Yep, 16 is right, because each time you invoke, the subroutine XYZ, you are doubling the value of whatever Y has. Yep. Are there any other questions about this trace? No other questions?
This is all we're doing for homework also?
Your homework is a little bit different. It's not multiplying, by 2, so it has some other thing to do. But there's also a second invocation of invoke at the end. So we have, like, imagine you have a line 11 here, which is also invoke XYZ.
Oh, yeah.
So that may or may not be a tricky one. So you have to kind of decide for yourself what your program is supposed to do. All right. So once this is done, we move on to the second question. The second question has the concept of arrays. It also has the concept of mod. In other words, I'm pulling different concepts from different parts of the lecture and kind of putting them together. And that's a fairly typical thing that I do in my exams, in the midterms, and also the final exam, is I'll pull things, from different contexts when we talk about stuff, throughout the semester, and then kind of put them together in a slightly new way. Yep.
What is mod? Remember the remainder?
Yeah, it's to find the remainder after the division.
Yep.
So
I'm not familiar with that.
This is what we talked about when we deal with the factoring program, and also the code to find a factor given a number.
We did cover that briefly.
Yep.
5 mod 7's 2, right?
Yep.
Yeah, that's right.
Yeah,
Okay.
1, yeah.
It's coming back to
It's
me.
all coming back. Okay, so you just have to make sure that on the day of the exam,
It
you
all
have
comes back.
Yep, yep. Or if you think that you might still need some help, write it on a piece of note, or bring all the notes, from Moodle. Yep, it's open book, open notes.
Well, that's the good thing about the practice test. I'm glad you put these up here, because you can practice all these, and then you can bring all that stuff in.
You can bring all that stuff. You can bring your homework. You can bring the solution of the homework that I worked on during class. You can bring all of those too. You can take screenshots from YouTube and bring those too. In the past, I have exams scheduled in the lab, and I have seen people watching YouTube while answering the test. So they plug in the headphone and they were watching my own YouTube, during the test. It's like, okay, text something, said something about this like 4 weeks ago. But I cannot remember what he said about that.
So why not listen to
Not
it
really
again?
the best way to do things because it's not efficient doing it that way. But they do it.
Time consuming.
It is time consuming unless you have an index.
Yeah, exactly. Where if you know specifically which day to go to and approximately what time of the day he said.
Right, but people who keep a good index of my class time and
Don't really
recording,
need to do that.
most of the time they're already paying attention in class and they're doing all the other things needed to get the material. They don't need it anymore. All right, so let's go. Let's copy the algorithm first. Okay, I get 0, J gets 0. We have a repeat here. I gets I plus 7 mod bar a bar. So I'm mixing and matching stuff together. This reminds me of crossover universes. Someone complained in the previous class that it looks more clear with extra parentheses, so I'm gonna put in extra parentheses. All right, so that's the algorithm. And the question is, when the algorithm completes, I want to know the values in each element of the array of 5 elements. Okay? And it's stated clearly here that you can assume that array A has 5 elements. So when you trace it, you know exactly how many elements you're supposed to deal with in this particular program. All right. And I have another one tracing.
Got a lot of programs.
Yeah, we got a lot of stuff, but that's okay. We can deal with it. All right, so now let's go ahead and do the indentation first, and then we'll trace it. And this may look like an infinite loop, but it's not. We got comments, line numbers, two variables I and j, and array A. Array A has 5 elements. Like so. And let's shrink all of these. And everything starts with unknown values. In other words, unless I tell you that a particular variable, you can make assumptions. If I don't give you any assumptions or initial values, you can basically say, okay, they all start with some kind of unknown value. Line 1 is initializing I to 0. Line 2 is initializing j to 0. We don't trace line 3, we skip all the way to line 4, because line 3 doesn't really do anything, so there's really nothing to say when I get to line 3. On line 4, I have to compute the right-hand side first. So here's the part, okay, what is the right-hand side of line 4? Well, you have to do it, using the parentheses. So I'm calculating the sum of I and 7 first. I, at this point, has a value of 0. 0 plus 7 is 7. 7 mod 5 is what? Is 2. That's right. The remainder of 7 divided by 5 is 2. And so I gets a value of 2. On line 5, I am going to use j, which now has a value of 0, to update a bracket I. I has a value of 2, so we are dealing with a bracket 2. A bracket 2 is column G. Column G is the one that is getting a value of 0 in this case. Yep.
I have another question about the mod. How did you get, I guess I'm still confused, 7 mod, bar A bar.
What is bar A bar?
Is 5.
Yep.
So 7 minus
What is the
5.
remainder of 7 divided by 5?
So mod is a division?
It's the remainder of division. Yeah.
So
It's the
mod is-
remainder.
You can look at it as a divisor
Like-
plus the remainder.
You see the division up there? How 5 divided by 10 is 2 with no remainder?
10 divided by 5.
So it's 5, or, I mean 10 divided by 5. So 10 mod 5 would be 0 in that circumstance.
It's the remainder of the division.
By
The
the
first-
number, by the number of elements in the array. By the number of elements in the array.
So it's 7 would be the 10.
Yeah. Yeah.
Bar A,
Well,
bar
obviously,
Yeah.
the numbers will be different, right? If you have 7 here, then you have a quotient of 1, but you have a remainder of 2.
Can you take the remainder?
Yeah, the thing in the box.
Yeah, that's what mod does.
Yeah.
Okay.
Yep.
Oh, it looks good.
Okay, aren't you glad that we are going over these things, in the practice test?
Very much.
Yes, yes.
Okay.
So then whatever the remainder is what mod is asking for.
All right. On line 6, we are just adding 1 to j. J goes from 0 to 1, and then on line 7, we check the condition. Does I equal to 0? Nope.
They're serenading your algorithm.
There's no classes going on.
It's a free country. We are free to play our music. You are free to teach your class. Yes.
Even if our music makes it a little bit more difficult for you to express that freedom.
It looks like a flea market.
In fact, they have to complain that we have classes while they're selling stuff when you guys should be out there buying stuff from them. So I am actually, anti-capitalistic here. Attack, the communist, supporting open source and all that stuff.
Not
It's like
even
crazy
red.
man. Crazy man. Okay, we're back to line 4. So on line 4 this time we have I being 2, right? So 2 plus 7 is 9. 9 mod 5 is 4. That's right. Okay. And then we move on to line 5. A bracket I is A bracket 4, which is column I. I use J to update column I. J currently has a value of 1, so column I is now updated to a value of 1. Are we still doing okay so far with this one? Okay. So the question is, do you think this loop is going to end?
Yes.
Because
Sure.
okay. On line 6, because it doesn't seem like that, okay?
At first glance, it doesn't, but if you know,
Yep.
look at it.
Give it a chance. Well, we cannot make a conclusion yet because I have not seen 2 iterations of this loop not changing any values. So I cannot really make a conclusion and say, oh, this is an endless loop. We cannot see it. We cannot see any recurring patterns either. All right, so on line 7, we are evaluating I equals to 0, which is also false because I is now 4. 4 does not equal to 0. We go back to line 4. On the right-hand side, this time we have 4 plus 7, which is 11. What is 11 mod 5?
1.
Okay, it's just 1. And on line 5, we update a bracket 1 with the value of j, which is 2. And then on line 6, we just add 1 to j. J goes from 2 to 3. And then now we are back onto line 7. I equals to 0 is false because I has a value of 1. So at this point, I'm going to split the screen so that we can see the header at the same time. So it just makes it easier to trace. We are now back to line 4 because the condition of the exit condition is false, so we have to go back to the beginning of this loop on line 4. The right-hand side is I plus 7. I is now 1. 1 plus 7 is 8. What is 8 mod 5? 3. Okay. So we go to line 5. A bracket I is A bracket 3 because I has a value of 3. So we are dealing with column H on the left-hand side. The right-hand side is easy, which is just the value of j. The value of j at this point is 3. So we update A bracket 3 with the value of 3. We move on to line 6. We add 1 to j. J goes from 3 to 4. And then we go to line 7 to reevaluate the exit condition. The exit condition is false because I has a value of 3. 3 equals to 0 is false. We go to line 4 again. This time on line 4, we have to evaluate the right-hand side. 3 plus 7 is 10. 10 mod 5 is 0. Ooh, okay. And then on line 5, we need to update A bracket 0 because I has a value of 0 with the value of j. So the value of j becomes the value of A bracket 0. And so we put a 4 here. On line 6, we increment the value of j, so it becomes 5. And then back onto line 7, we ask the question, is I 0? The answer is true, and we are all done. Yep.
If you mod a number that's bigger, so it could be like 5 mod 7, would it be a decimal?
No, because it is still a remainder.
There's still two left over.
Okay. Oh, it's exactly.
No, 5 mod 7 is 5.
Oh yeah.
Because 5 divided by 7 has a quotient of 0, but a remainder of 5.
Okay. So they just wrote it.
All right. So it's good. It's good that we are reviewing all this stuff, at this point. Yep.
On the second line 4, can you explain to me how we got the answer up top?
Which one?
The second line 4.
The second.
From the top.
The iteration.
Which row?
It's up top. It's like number 6
Oh,
or
I see.
7.
Okay, this is the row number. You can use the
Line
row
10.
number. Row 10. This one. Are we referring to this row?
Yes.
Okay, so on this row, we are on line 4, and we want to use 1 plus 7 mod. Is it? No, it's 2. I has a value of 2 at this point. So 2 plus 7 mod 5 is 9 mod 5. 9 mod 5 is the remainder of 9 divided by 5,
Got it.
which is
Okay.
4. Yep.
I was looking at 4. I was adding 4. Okay. That makes sense.
Okay. And that's really the nice part of a trace is like this. Okay, we can go refer back to any row in a trace and figure out, okay, what happened, on that line, and I can explain that, again, after the fact. It will be difficult to do that without a trace because then I would just be, okay, we have no evidence of, what happened, during the execution of the program. Whereas this way, it is, we have an entire trace, an entire log of what happened. All right, so is this particular question okay? So the correct answer to this question is just copying the value of A bracket 0, which is 4, and then the value of a bracket 1, which is 2, the value of a bracket 2, which is 0, the value of a bracket 3, which is 3 itself, and also the value of a bracket 4, which is 1. That's the answer. Yep.
Let's say for whatever reason something was a little different and it didn't place a value in that and then ended. Would we just put a question mark?
Yeah, you can just put a question mark there.
Okay.
For practice purposes, what you guys can do is to change the program just very slightly. So instead of adding 7 here, you can choose 8 would be fine. Okay, if you choose 8, the pattern will be different. It will still fill all 5 numbers before it exits, but the pattern will be different. Okay. Are there any questions about this particular program? But it would be fun. I mean, just change this change 7 to 8, and then you can change it to, would 9 work? 9 should work too. Yeah, the only time it doesn't work is when the number that I'm highlighting here is a multiple of 5. Then it doesn't work well. All right, so this one is done. Let's move on to question number 3. Question number 3 looks really nasty, but it's not. It's actually one of the more straightforward type of questions because it is really just tracking down the subroutines. There's no recursion, there's no tricky returning and stuff like that. It's just okay, this calls that calls that, and so on. You just have to kind of keep track of all of that stuff. All right, so let's go ahead and take a look at this one, and I'm going to change the algorithm slightly because from the previous class I can understand why the question itself is confusing. So I'm going to change it to a form that is less confusing, and we'll trace it like that. Okay. All right. So we'll go ahead and define subroutine. Define sub 1. X gets x plus 1, and I'm intentionally leaving one line empty here. Okay, and then we'll have n define sub, and then we have define sub 2, invoke sub 1, x gets x plus 1, and let's see, is that line 5? Yep, that's line 5. I have to leave an empty line here as well. So I'm going to copy and paste in here, and define sub. Define sub 3, invoke sub 2, leave an empty line here, invoke sub 2, leave an empty line here, and define sub, invoke sub 3, invoke sub 1. Okay. Well, the reason why I intentionally leave some lines empty is because I can now say, okay, at this spot, what is the value of x? And you have to tell me the value of x at that spot. And some of these can be traced multiple times, so you have to tell me the value of x for each time we get to that line. Do you have a question?
Was there a reason why you left out x gets 5? 5 12?
Oh, I forgot about it. There's no reason that I forgot. There's no reason that I leave it out. I just forgot. There we go. Okay, so that's line 1, 2, 3, 4, 5, 6, 7, 8, 9. This is line 10, 11, 12, 13, 14. I'm just doing the checksum, so everything kind of adds up correctly. All right, so we'll number this line 2.5. We'll number this one line 5.5, 9.5, and 10.5. Okay. So the question is, if you read the original question, it's basically you telling me what will be the values of x when we get to those particular lines. Now they're empty lines with a 0.5. Okay. So we'll trace it first, and then we'll kind of decide how to answer the question. All right. What I'm trying to do is I still want to make sure that you guys know how to trace an algorithm, but I don't want to have to look through the entire trace to give you the score. So I'm giving you this kind of question so that you still have to do your part to trace it. But in terms of rating, I'm just looking at the values of x at certain times to see whether you actually finished the trace correctly or not. Obviously, we still have some indentations to be done. So we got this one, these two. All right, so we got the indentation done. And now we can actually start to trace the algorithm. starting on line 12. We don't have any comments, so we can start with line number. In this case, there's only one single variable, x. There's no assumption. X starts with an unknown value as a precondition. The first line to execute is the first line outside of the definition of a subroutine. In this case, it's line 12. Line 12 is saying x should start with a value of 5, and then we move on to line 13. Line 13 is an invoke statement, so even before I know what it is invoking, I know I have to allocate a column for return line number and write down line 14 here because the invoke is on line 13. Then I ask, okay, which subroutine are we invoking? Sub3. Okay, find where's sub3. Sub3 is defined on line 8, so now we have to go to line 9 to continue execution. Line 9 is invoking another subroutine, so we have to do the same thing. Allocate the leftmost available column, and then write down the next line that we're supposed to go back to. In this case, we do have line 9.5, so I'm changing line 10 to line 9.5. We're going to go back to line 9.5, even though there's nothing to do on line 9.5. But it will still be appearing on the trace, and we can still use it to indicate what we should write down as the answer to this question. After we remember where we're supposed to go back to, we have to go to the subroutine that line 9 is invoking, which is sub2. Sub2 starts here, and line 5 is the first line inside sub2 that does something useful. So we continue execution on line 5, which is another invoke statement. We allocate the leftmost available column, and remember where we're supposed to go back to. It used to be line 6, but now that we have a line 5.5 after line 5, we'll write down line 5.5 here. Okay, so line 5 is invoking sub1, and sub1 starts on line 2, and that's the first line that does any calculations. 5 becomes 10 because we are just doubling the value and put it back into x. On line 3, line 2.5. Line 2.5 really doesn't do anything, but I'll put it here in the trace just because we want to know, okay, how to answer the questions later on. And then we move on to line 3. Line 3 actually does something useful because it has to look up the rightmost active return line number. In this case, it's column E. It tells us to continue execution on line 5.5. Okay, so we'll make a note of that we have to continue on line not 5.5. But once we use the value or the information on a return line column, return line number column, we have to deallocate that column. So now the column is deallocated. And then we continue execution on line 5.5. 5.5 is a null statement. It doesn't really do anything, so we just move straight on to 6. Line 6 is adding 1 to x. X goes from 10 to 11, and then we move on to line 7. Line 7 is the end of a subroutine, so we have to do the same thing that we always do at the end of a subroutine. Locate the rightmost active return line number. This time it's column D. It tells us to continue execution on line 9.5. So we make a note of that. And then we have no use of column D anymore. We deallocate it. Now that we are on line 9.5, it doesn't do anything useful either, so let's just move on to line 10. Line 10 is another invoke sub2, so now we have to allocate the leftmost available column. Which one is our leftmost available column at this point?
D.
Column D. Okay, column D is our leftmost available column. Because column C is still in use, nobody has deallocated column C at this point. So column D is the leftmost available column, reallocated for the purpose of remembering the return line number. In this case, the return line number is 10.5 because I just put in this empty statement here. And then we can continue execution in the subroutine that we're invoking, which is sub2. It starts on line 5. Line 5 invokes sub1, which means we have to allocate a return line number column. And remember that we have to go back to line 5.5. And then we can go into sub1 and continue execution on line 2. Line 2 is just doubling the value of x and store it back into x. And then we have line 2.5, doesn't do anything useful. It's only here so that we can answer the questions later on. And then we move on to line 3, which is the end of a subroutine. Look up the rightmost return line number that is still active, which is column E at this point. It tells us to continue execution on line 5.5. And then we have no use of that column anymore. It is time to deallocate it. We are now on line 5.5. It doesn't do a single useful thing. We continue on to line 6. Line 6 is just adding 1 to x. It goes from 23 to 24. Now we are on line 7. Line 7 is the end of a subroutine. We look up the rightmost active return line number column, which is now column D. It tells us to continue execution on line 10.5. Once I use that information, I have no use of column D anymore. It is time to deallocate that column. Now we are on line 10.5, which doesn't really do anything, so we move right on to line 11. Line 11 is the end of a subroutine. Now we have to do the same thing, look up the rightmost active return line number, which is column C in this case. It tells us to continue execution on line 14. All right, so let's go to line 14. And once we make use of that information, once again, we have no use of column C anymore because of that. Now we are on line 14. Line 14 says invoke sub1. So we have to reallocate the leftmost available column, which is column C at this point. And remember, okay, since line 14, there's nothing after line 14, so that means the return line number is going to be post. And then we continue execution in sub1. Sub1, starts here, which is on line 2. And all line 2 is going to do is to double the value of x. It goes from 23 to 46. And then we get to line 3. It is the end of a subroutine. Sorry?
2.5.
Oh, yep, sorry. There's a 2.5 here. And then we move on to line 3. Line 3 is the end of sub 1. So we have to look up the rightmost active return line number. In this case, it's column C. It tells us to continue execution at post. And once we make use of that information, we can deallocate that column. And then we can continue execution at post, which means we are all done. All right. I think I bored myself.
Yeah, that's a lot of talking.
That's a lot of talking, that's right. Yep. That's why you might want to turn down the volume when you're going through this. It's like, okay,
I don't
turn on the
use
music.
right now.
Use a mixer. Crank up the music and crank down the talking.
You should have the voice presets to say that it's time to deallocate.
I think some creative students in this class can make a song out of this the discussion of how to trace an algorithm. Just add some melodies, add some tune to it, add some beat. Who knows? It might go viral. The next viral YouTube, how to trace an algorithm.
Yo man, Dr. Ted.
Yep. You can pick a picture of me and then do the jib jab thing. You cut out the mouth part and then go like that. And then cut off the hands, so you can kind of wave around. That takes time. That you should be doing your homework. Yep.
Yes, that is.
Or studying. Yep. All right. So getting back to the question now. Okay. So the question, which is not really asked in a very clear way. So now that we have the 0.5s, it's really asking on line 9.5, what will be the value of x? So in order to answer the question, all you have to do is to go this trace here, and you say, okay, line 9.5 is here. X has a value of 11 at this point. Okay. And then the next one is, what is the value of x at line 10.5? At line 10.5, which is down here, x has a value of 23. What about line 5.5? Now that's a little trickier, because there are several times we are on line 5.5. So the first time we are on line 5.5, x has a value of 10. The second time we are on line 5.5, x has a value of 22. So you write down 10, 22 in that case. And the last one is line 2, and I think we are on line 2 3 times. Okay. So the first time is over here. On line 2.5, x has a value of 10. The second time is here, x has a value of 22. And the third time is here, x has a value of 46. Yep.
What was so complicated that you had to throw in the 0.5?
It's just, some people do not understand, okay, do I write down the value of x before the invoke or after the invoke? That's why it was confusing. Okay. But once I introduce the 0.5 line, it becomes very clear. Okay, every time you step onto this 0.5 line, tell me the value of this particular variable. So are there any questions about question number 3?
Wait, so there could be more than one answer then?
Yeah, you have to separate those values by commas.
Okay.
Yeah, so on line 5.5, there are 2, and then on line 2.5 there are 3 values. Yep. So basically this is, it serves multiple purposes. One is I can at least give you partial credit. So for people who cannot finish the entire trace, either out of time or they just, they got bored of answering a question in a test, they can still get partial credit, assuming the first part is still correct. Or they make a simple calculation mistake and instead of adding 1, adding 2 or something like that, they can still at least get partial credit. It's also easier for me to grade because now I can look at those values and assign partial credit and say, okay, if you get this part right, at least you'll get that answer. But the sequence has to be right. Because I don't want, as I told the previous class, I don't want anyone to play lotto with me. Like just throwing out a bunch of numbers and say, okay, I'll just write out 1, 2, 3, 4, 5, 6, and then attack. You said that, let's say 22 is the right answer, okay? And 22 is within this list of numbers, so you gotta give me that partial credit. No, okay? Because the order has to be right. Because knowing some of my previous students, that student is not in this classroom right now, so you don't have to worry. But knowing some of my previous students, that's exactly how, what kind of response I would get. It's like, but you said 22, you will get partial credit, and I listed everything from 1 to 100. I should get a partial credit too. Nope.
You should lose credit for wasting time.
Yeah, you guys have no idea what kind of students I have gotten in this class in the past.
I'm sure you've had.
Let me just say that I got some pretty good lawyer material. All right, question number 4. Now, question number 4 is, it looks kind of long and nasty, but it really is not. Okay, so we'll go ahead and trace this. Well, it looks long, but it's not really that long when you trace it. Okay, and it has arrays, so most people look at this and go like, "Ooh, that doesn't look very good. It looks kind of nasty." Well, when you trace it, it's not really that bad because the resize on you. All right, let's try that. All right, so what we'll do is, we'll copy the algorithm first. But as I'm copying, I will also kind of explain, what each one is doing. Okay, we are comparing 2 array elements here. They're adjacent, one and then the next one, and see whether the first one is greater than the next one, the one next to it. If so, we go through this sequence of assignment operations. This sequence of assignment operations, the only thing it does is to swap the values of 2 things. So in this case, I'm swapping the values of a bracket I and a bracket I plus 1. Okay. The second subroutine, gives me the overall structure or the loop for this particular code. So we get I get 0 is here, while I is less than bar a bar minus 1. Okay. And then we have invoke ABC, I gets I plus 1, and while and sub, invoke def. Okay, so let's fix indentations first. And then we can do a shift click. Oh, no, not shift click. Okay, we do a control click here, and then a control shift down to here. There we go. Do one indentation, and then we have this, and then this, and this to do another indentation. There we go. And by the way, this is actually one of the steps of bubble sort. Remember, we kind of talked about bubble sort. This is one of those steps in bubble sort. And then we want to look at the other window for the trace. go. All right. We definitely have conditions to evaluate, and we have variables I and t, and then we have array A. According to the question, array A only has 3 elements, and the values of those 3 elements are 3, 5, and 4. So those are initialized to begin with. That's a part of your precondition. So we got bracket 0, bracket 1, and bracket 2. 3, 5, and what? 4. There we go. Those columns. T starts with an unknown value. I starts with an unknown value. So those are fairly narrow columns. Line number doesn't need all that space, so we can limit it. And now we can trace the algorithm. This is my precondition. We start execution on the line, the only line in this case that is outside of the definition of a subroutine, which is line 15. On line 15, we invoke DEF. So this time we have to allocate column H because it's our leftmost available column, and we use it for return line number purposes. The return line number in this case is post because after line 15, there's nothing else to do. So when we come back from this invocation, we can say, oh, we're all done. Then we continue execution on the first line of DEF, subroutine DEF, which is on line 9. Line 9 doesn't do anything too exciting. I gets a value of 0. And then on line 10, we evaluate the condition. I is 0 at this point. Is it less than bar A bar, which is 3 minus 1? 3 minus 1 is 2. 0 is less than 2 is true. We move on into the loop itself. We move on to line 11. Line 11 is an invoke statement. We have to allocate the leftmost available column for return line number purposes. And line 12 is where we have to continue execution when we come back from ABC as a subroutine. And then we move on and continue execution in subroutine ABC starting on line 2. Yep, go ahead.
If line 10 is false, is it instantly just post?
No. If line 10 is, if the condition on line 10 is false, we get to line 14, and then we have to still do the return, and then we can get to post. Yep. Okay, so here's line 2, and line 2 is a comparison. So now we have to compare A bracket I, which is A bracket 0, and compare that to A bracket I plus 1. But in this case, you have to evaluate I plus 1 first. So I is 0, I plus 1 is 1. We are comparing A bracket 0 to A bracket 1 and see if the first is greater than the second. The answer is false. That is not true. Since it is not true, we skip over the big mess in between, and we get to line 7 right away. Line 7 is the end of a subroutine. We have to locate the rightmost active return line number column, which is column I. It tells us to continue execution on line 12. We make a note of that, and then we have no use of that column anymore. We deallocate it. Now we are on line 12. Line 12 is just adding 1 to I. I goes from 0 to 1. And then we go back to line 10 to reevaluate the condition. I is now 1, bar A bar minus 1 is 2, 1 is less than 2 is true. So we move on to line 11 to perform the second iteration of this loop. The second iteration has to do an invoke first. So we are reallocating column I because column I at this point is the leftmost available column. So we are reallocating it for return line number purposes. The return line number is still 12 because the invoke is on line 11. And then we continue execution at the beginning of subroutine ABC, starting on line 2. Line 2 is comparing A bracket I to A bracket I plus 1 like last time. I at this point is 1, so we're comparing A bracket 1 to A bracket 2. A bracket 1 has a value of 5, A bracket 2 has a value of 4. 5 is greater than 4 is true. So this time we do have to get into the then branch of the conditional statement, starting on line 3. T is getting the value of A bracket I is 1, so T is getting the value of A bracket 1, which is 5. On line 4, we are copying the value of A bracket I plus 1, which is A bracket 2, which is a value of 4, to A bracket 1. So column F is updated to the value of column column G, sorry. So it's getting a value of 4. And then on line 5, we are copying the value of t to a bracket I plus 1. I is 1, 1 plus 1 is 2, so a bracket 2, which is column G, is getting the value of t, which is 5. Are we still doing okay so far with this code? Just going to show you the header information so we can at least keep track of those particular values. So after line 5, which is the last line of the then branch of the conditional statement, we get out of the conditional statement, and then we end up on line 7. On line 7, it is the end of a subroutine. We look up the leftmost active return line number. In this case, the leftmost active return line number is column I. It tells us that our return line number is 12. So we make a note of that, and then we have no use of column I anymore, so we deallocate it. Like so. Now we're on line 12. Line 12 is just adding 1 to I. I goes from 1 to 2, and then we go back to line 10 to reevaluate the condition. The condition is comparing I to bar A bar minus 1. Bar A bar is 3, 3 minus 1 is 2, I is 2 as well. 2 is less than 2 is false. So we get out of the loop, and we end up on line 14. Line 14 is the end of a subroutine. We look up the rightmost active return line number. Column I is no longer it because it is now deallocated. Column H is still active, so it is telling me to continue execution at post. I will make a note of that. And then we have no use of column H anymore, so we just indicate that it is now deallocated. We are now at post, and this is all done. So are there any questions about this trace? A little tedious, this one does require you to do the calculation inside the square bracket instead of putting the +1 outside of the square bracket. But other than that, it's just a little bit tedious and a little bit of subroutine stuff, but nothing really too super duper tricky. Okay, are there any questions? Are you guys all set for the break? Yeah. Stuff to catch up, sleep and all that stuff. Yep. All right. Well, I guess I'll give you guys, an earlier break by 3 minutes. First. Yep, you can sign. But it's probably best to be on time.
Usually we're technically 3 minutes.
I have a test today, and
okay.
There was a sleep group.
Oh, okay. Yep. All right.
Sorry.
Understood.
But I always listen to a lecture on YouTube.
That might be helpful too. Yep.
I think it's something like 6 or something.